We've talked about water and the chemistry of water and the molecular views, but let's take it to a bigger level on the macroscopic scale, the water we drink. So where does the water you drink come from? So it doesn't matter where you are in the world, it's important to know where your water comes from.
To be very honest, I'm not sure where my water comes from, so I'm going to Google it right now.
I really don't know where my water comes from. I have no idea where my water comes from.
I would say my faucet.
I assume my water came from the tap.
I don't know where my water comes from. That's why I put it through the Brita before I drink it.
I actually drink tap water. My water comes from the tap. I'd like to think it comes from the Potomac watershed.
Well, I'm not sure. I'm guessing it comes from the Potomac River.
I'm from Maywood, New Jersey. My water comes from the Oradell Reservoir.
Well, I go to UEA, and at school, the water's from the Rivanna Reservoir.
I think it comes from Potomac River.
Where I live, my water comes from a well.
I think the majority of my water comes from the Chesapeake watershed area.
My water comes from reservoirs and streams.
So before you jump off to go check where your water comes from, the video was recorded in New Jersey and Maryland, and so it depends on your location. Where we are in Santa Monica, or where I am, are from the watershed. That's the best answer. But the water comes from all over in this watershed. So it's a big area. Some comes from the Colorado River. Some comes from the Hetch Hetchy Reservoir, which is way up in the Sierras, which comes from snow melt, which makes the water particularly pure. And then some's from reclaimed water, and some's from local wells. But the majority is Colorado River and the Hetch Hetchy Reservoir that looks like this. So this is snow melt from the Sierra that is captured in a reservoir, and then it's pumped down here to Southern California. Why is it important to know where your water comes from? Because the water you drink every day is also for cooking and for cleaning, and that goes into your body. And so just as the air you breathe is important, the water you drink is equally as important. You want it to be clean and unpolluted, just like the air you breathe. So we're lucky that we have the Environmental Protection Agency that has standards for the air pollutants, but also for water pollutants. And so this is how we have clean water in the United States, that it is monitored by the EPA. So clean water that is drinkable is called potable. And the question is, where does that drinking water, that potable water, come from? So we know the earth is a big blue marble because of water, and we know that water enables life on earth. However, of all the water on earth, only a small percentage of it, only a fraction of that water that we have on earth, only a fraction of it we can actually drink. So 97% of the water that we have on earth is salt water. We can't drink that. You can, but it's not going to serve your needs to remain as a living being. So 3% of that, the remaining 3%, is fresh water that we can drink. Now, of that 3%, 70% is tied up in ice and glaciers. And so we have water that is available on the surface that is not as ice, but in lakes and rivers and atmosphere and moisture, but that's 0.3%. So if you take all the water on Earth and put it in a 2-liter bottle, about 4 drops of that 2-liter bottle is fresh water that we can access for drinking. Okay, that is unpolluted as well. And so that's why there's an issue that is going to be discussed, which is water scarcity, and that not all countries have the same accessibility to this 0.3% of drinking water that's available on Earth. So there's potable water. That's when you have fresh water that's clean. That's drinkable water. Surface water is what we can actually access at the surface, so lakes, rivers, and reservoirs. And then there's groundwater. This is underground water that is stored in aquifers. An aquifer is a reservoir underground. So it's like having a lake or a river underground. And this has to be pumped up. And so that's called groundwater. And not all countries have groundwater. Drier whole continents don't, or maybe it's ice and that you can't pump up ice. And not all countries have equal access to surface water because there's, countries are split up differently on the continents. So you may ask, what about all this ocean water? Can we use any of that? Well, we can use ocean water if you remove the salt. So oceans have a lot of salts, that's NaCl, but a lot of other ions are in seawater. And so removing the ions, like the sodium ions and the chloride ions, requires energy. And so this is a process that we'll talk about at the end of the chapter called desalinization, removing the salt from seawater so we can make it drinkable or potable water. That takes energy, and as anything that takes energy, where's that energy coming from? In the U.S., much of our clean drinking water comes from these underground aquifers. This is the United States, and there's actually a giant underground lake, the Oglala Aquifer, that's shown in dark blue. And so this is underground, so it should not have any water pollution because it can't be accessed. But the thing is that this area of the United States, this is a huge agriculture land. So this is farm country, and it has been drained by all those states for agriculture, for growing corn in Nebraska, or for growing wheat in Kansas. And so this is an example of tragedy of the commons, is that this is a shared resource, this Oglala Aquifer, but all these states have used it, nobody's in charge of it, and it has been overused, and it actually is is subject to some pollution because water, fertilizers, chemicals, they all eventually do make their way underground, as well as there being local septic systems, local chemicals, and all that makes its way underground and can basically pollute this entire aquifer. To safe drinking water is not equal around the world. So these are all the countries shown. We have over 75% in North America and over 90% in the United States. Europe is also doing fine, 90%, including Russia. But countries that have less than 60%, so less than 75%, 60 to 75%, these red countries. But what's more dangerous is when we're getting into the purple and brown and this lighter purple. So these are countries in Africa. So this is the whole continent of Africa, and countries here, many of these countries do not have access to safe drinking water. In Africa, about 75% of the people living in the various countries in Africa have no access to drinking water. So if you get thirsty, you can go downstairs and turn on the tap. There's no taps there. There's no water. There's no infrastructure, and there are issues with accessibility.